What's going on, guys? Welcome back to another video. This one, our final one, seems crazy, doesn't it? It's the at-home assignment number 19 over geometric sequences. You've probably seen this before. I'm not sure what grade. You'll see it isn't too bad. So, quick recap on geometric sequences. It's just a sequence that you multiply or divide to get the next term. If you remember, a arithmetic sequence is similar, but you add or subtract. And a common ratio, it's that ratio or the number that you're multiplying to get the next term. And then finally, the recursive formula, we'll discuss about that in the second page, but it just helps us determine the next terms in the sequence by using the sequence's previous terms. So on these first six, all you're doing is you're determining if we have a geometric sequence. If we do, we then need to write the common ratio and then the next two terms. So here, first determine if it's a geometric sequence. Try to see what's happening between each of the terms. So between 5 to 15, what am I multiplying, adding, subtracting, dividing? Looks like I'm either multiplying by 3 or adding 10. So let's say multiplying by 3. Let's see what happens from 15 to 45. Well, one of the possibilities was adding 10. Well, clearly 15 plus 10 is not 45, but 15 times 3 is 45. And so on. 45 times 3 would be 135. So here for number one, yes, we do have a geometric sequence. Now, instead of saying common ratio, we're lazy, aren't we? We'll say C dot R. So my common ratio here is going to be a 3. And then finally, my next two terms. So let's continue on with this sequence. We now know with this sequence, we have a common ratio of 3, and it ended with 135. So to find the next term, we'll do 135 times 3, which is 405. And then to find the next term after that, we'll multiply that number by 3, and we'll get 1215. So that's the same thing we're going to do for the rest of these first six. So look at number 2 here. What's happening between the first one, 17 to get to 13? Oh, we subtract 4. And same thing here, subtract 4, and then subtract 3. So we know that this is not a geometric sequence because the ratio here, we're subtracting 4 and then also subtracting 3. So it's not even consistent. But we are not multiplying or dividing, which means it is not a geometric sequence. Thankfully, when that happens on this question, we could just leave it like that and we're done with number 2. Let's see for number 3, 2.5 to 5. Well, there are two ways to get there. We can either add 2.5 or multiply by 2. We generally want to multiply, so let's see if multiplying by 2 works every time. So multiply by 2. Okay, well, 2.5 here, if you notice here for the next one, we multiply by 2 again, and we multiply by 2 again, and hey, looks like with this, it is a geometric sequence. So I'll just say yes, it is. Next part, let's find our common ratio, or I could say C dot R. It's going to be 2. And then let's find our next two terms. Now our next two terms again, you just continue this pattern. So we left off with 20. So let's multiply 20 times 2 and we'll get 40. And then multiply 40 by 2 and we'll get 80. Number 4, let's see what's happening here. 7 to negative 7. We're either subtracting 14 or multiplying by negative 1. If we were to say multiply by negative 1, so times negative 1, does that hold true for the next term? So between negative 7 to positive 7, hey, a negative times a negative is a positive. Looks like that does hold true. And it looks like it holds true for this final pair as well. So it looks like that yes, I'll do a different color. Yes, it is a geometric sequence. And since it is, we have a common ratio of -1, and this isn't too bad to find the next two. We'll just do the same thing we've been doing. So let's take that last term, which is -7, and let's multiply by -1. A negative times a negative is a positive, therefore it's a +7. And then the final part there is 7 times -1, which would be -7. Cool here, number 5. We'll do the same thing. 81 to 27. Looks like we're not multiplying a whole number. It looks like we're actually dividing by 3. And the same thing here, 27 to 9, we're dividing 3. And then 9 to 3, we're dividing 3. Now notice this whole time with the common ratios, we've been writing it as a way of multiplication. So instead of saying dividing by 3, we can actually say we are multiplying by 1/3. You remember that keep, change, flip thing? It's kind of similar to this. So here, 27 times 1/3 is going to be 9, and then 9 times 1/3 will be 3. So yes, this is a geometric sequence, but here my common ratio, we're going to want to keep it at the multiplication phase. So let's say we're multiplying by 1/3. And then finally, our next two terms, well, let's keep doing the same thing we've just been doing. So let's take 3 and multiply it by 1/3 or divide it by 3. It may be easier to think of it as dividing in your case. So we'll do 3 divided by 3, which is 1. And then you'll do 1 divided by 3 as well, which is just 1/3. And then number 6. So what's happening between 3 to 9? Okay, well, we know that's multiplying by 3. 9 to 81. That's multiplying by 9. And it looks like what's happening here is actually that's 81 times 81. These are squaring each other. Now, even though it's multiplying, this is not a geometric sequence because there's not a common ratio. Again, this is not a geometric sequence because there's not a common ratio. While yes, they are multiplying, they're not multiplying the same number. So number 6 is no. This is not a geometric sequence. Sweet. So let's go on to the recursive definition of geometric sequences. So we have two different ways to display the recursive definition. And again, as a reminder, the recursive definition, it just helps us determine the next terms in a sequence by using the sequences, is a big thing here, previous terms. So we're going to use the previous terms to help us get the next terms. There's two different ways to write this. These are the same. There's just different ways to write it. So here we have two parts. Notice for all this, we have two parts, an A1 and an AN. So let's look at function notation. We're using function notation of seeing like f of x. Well, it's pronounced the same way, a of 1. That just represents your first term in your sequence. The next part, a of n. You have three individual parts here. A of n is the value of your nth term. R is your common ratio, so this thing we found above. And then finally here, A parentheses n minus 1, that's the value of the previous term. And the same thing for subscript notation. So this may be new to you. Notice it has like an A and a small 1. That small 1 is called a subscript. That is not, I repeat, it is not A times 1. That is not how you say it. You might be able to say A sub 1 or A1. Well, in this case, A1 is the first term in the sequence. And here, very similar to what we just saw, I'll even use the same colors. I'll use the orange first, perfect. So here, AN, that is the value of your nth term. The R is your common ratio. And not A to the A sub n minus 1, that's the value of the previous term. So these are both saying the same thing. They're just running a little bit differently. Again, subscript might be new to you, so this might get some getting used to. So I'll have some examples here for us to work out. So we have this sequence 7, 21, 63, and 189. With this here, we need to write the recursive definition in both function notation and subscript notation. So both of these notations. Well, first here, we need to write, let's do function notation. We need to find our A1. A1 is the first term in the sequence. So in this sequence, 7, 21, 63, and 189, our first term is 7. And we need to write a formula here so we can find every other term using the value of the previous term. So we need to find a common ratio. So what's happening between 7 to 21 to 63 and to 189? We know we're multiplying by 3 every single time. So that means here in my equation, A of n equals R times A of n minus 1. I'm going to say A of n equals my ratio, common ratio, which is 3, times my A of n minus 1. And that's it. So really, you're just filling in the first sequence, sorry, the first, the first value, the first term, my bad, wow, the first term of your sequence, and then you're finding the common ratio, and that's it. Same thing here, subscript notation. It's very similar. We saw that the first term was 7, and our common ratio here was 3, and we just leave it like that. So again, very similar, except that one of them has a subscript. Number 8, given this sequence, we do the same thing. So starting off here, we have our first term, which is negative 12. And let's find a common ratio. What's happening between negative 12 to negative 24? It looks like I'm multiplying by 2 because the same thing is for negative 24 to negative 48. Multiply by 2, and same thing here. So that means here, my common ratio was a positive 2. And I'm multiplying that by my previous term. Very similar to our subscript notation. So A sub 1 equals negative 12. And here, A sub n equals negative 12 times A to the n minus 1. And then our last practice problem on this section, given this sequence, write the same thing. So our first term here is going to be 3. And let's find our common ratio. So between 3 to 24, what number am I multiplying? Looks like I'm multiplying by negative 8. My bad. There it is. Cool. So that means here my common ratio again was negative 8. So that's okay for your common ratio to be negative. Just stick it out in front. And that's being multiplied by my previous term. Same thing for subscript notation. A sub 1, and that equals 3. So A sub 1, A sub n, my bad, is negative 8 times A sub n minus 1. Again, very similar looking. One of them is of, one of them is sub. Finally, Let's finish up with these last few. We need to find the indicated term of this geometric sequence using the information given. So here, they give us the starting value and they give us the formula already, or the recursive definition. Now we need to find this fourth term or this fifth term or whatever number they're looking for. So here's what I recommend doing. Let's go ahead and kind of just write out our sequence. So we know, and actually let me label it here, A1, A2, A3, and we're looking for A4. So we know what our starting value is. We know that A1 is 2. Not a surprise there. So A1 is 2. We know that. Now, we don't know what A2 is, but we do know what we need to multiply each term by to get A2 because we have a common ratio of 3. So that means here I'm going to end up multiplying all my terms by 3. So that means 2 times 3 is going to be 6. Same thing here on the next one. Multiply that by 3 and multiply the last 2 by 3. So 6 times 3 is 18. And then we'll do 18 times 3, and that would be good old 54. So that says that A of 4 is 54. Whoop. Sure, that's good enough. So that's what I recommend doing. Go ahead and write out all the terms leading up to it. And you already know the initial, and you already know the common ratio. So let's try another one. Try number 11. We're going to find the same thing. We're trying to find A of 4. So they give us our first term, which in this case is a 15. You cannot see that. That is terrible. And let me go ahead and write out my A1, A2, A3, and A4. Cool. So they give us our A1 already, which was, in this case, 15. Now, we have our common ratio, which is -2. So that means I am multiplying everything in my terms by -2. So here, 15 times -2 is -30. -30 times -2 would be a positive 60. And then positive 60 times -2, you guessed it, -120, except that looked terrible. That looks a little bit better. -120. So that means A of 4 is -120. There we go. Now we got some subscript notation, but it's still approaching the same thing. And we need to find A sub 5. So here, we'll need 5 terms. And again, and I'll make sure I'll match it. So here, so A sub 1, A sub 2, A sub 3, 4, and 5. So our first term here was a -4. Again, I found that because they just told me. Actually, I didn't find it. They just told me that. So that is my A sub 1. Now, to find my A sub 2, I need to multiply by my common ratio. And hey, my common ratio is a -6. So I'm going to multiply every single term by a -6. And that will help me find my A sub 5. So -4 times -6 will be positive 24. 24 times -6 would be -144. Now that times -6 would be 864. And times that by -6 would be -5,184. Oops, that's weird. 84. Perfect. So that means here my A sub 5 is going to be negative 5,184. And then finally, number 13. Probably a bad number to end on, but that's fine. So with this here, find the terms, and we have subscript notation, which is totally fine. Hopefully we're comfortable with it now. And I want to find A sub 4. So start out, write your starting value, and my bad, just so we're consistent. A sub 1, sub 2, 3, and 4. So starting out, we are starting out with negative 3. Oops. And we're having a common ratio of, it looks like, positive 4. So we're multiplying, not negative 4, positive 4. Multiplying all our terms by a positive 4. So negative 3 times 4 is negative 12. Negative 12 times 4 is negative 48. And then we do negative 48 times 4, which would be negative 192. And that was the last question. That was a terrible box to end on. That's better. Sweet. That was the last question and the last assignment. Hope you guys enjoyed this semester. Hope I wasn't too harsh with y'all. Enjoy it. Enjoy the summer and enjoy, hopefully,